we're going to derive the law of sines for the case where all the angles in a triangle are acute. The derivation for the law of sines for the other cases is very similar. So let me draw out a triangle whose angles are all acute. Now we're going to label the angles as following, and this is pretty much standard in any textbook that you look at. We're going to call this angle over here alpha, this angle beta, and this angle gamma. And then we're going to call the side length opposite of alpha A, this side length opposite of beta B, and the side length opposite of gamma C. So alpha, beta, and gamma are angles, and A, B, and C are side lengths. And it's the case that alpha corresponds to A, not equal to, but corresponds to it. Beta corresponds to the angle opposite the side whose length is B, and gamma is paired up with C. Now what we're going to do is we're going to drop an altitude down from one of the angles. I'm going to use B. So we're going to create a right angle there, and I'm going to call this length H. I'm just arbitrary. Call it whatever you like. Now I'm going to draw I've got two different triangles going on here. So the first triangle on the left side looks something like this. Where this side length is H, this is C, and this is alpha. Now what I can get from this triangle is that since this is a right angle down here, I can use my trig functions. So the sine of alpha is going to be equal to the opposite side, which is H, over the hypotenuse, which is C. So we're gonna hold this idea now, and we're gonna do the second triangle. So the second triangle looks something like this. Draw it as best we can here. And the side lengths and angles that we know here, we know that this is gamma. This length is still H. And this side length is A. So that's all according to the drawing that I have up top here. So that says, since this is a right angle, we can use our trig functions. So we have the sine of gamma equaling H over C. So let's use those two. And what I'm going to do is I'm going to solve this equation right here for H. So I'm going to get C times the sine of alpha is equal to H. Similarly, over here I have, whoops, what did I write down here? C, this should be an A. Okay, so H over A. So A times the sine of gamma is equal to H. And since they're both equal to H, we can say the following. We can say that C sine alpha is equal to A sine gamma. And now if I divide both sides by A and C, I get the following. I get the sine of alpha divided by A is equal to the sine of gamma divided by C. Similarly, we can show that the sine of alpha over A is equal to the sine of beta over B. So I won't go through that proof, but it essentially just involves dropping a different altitude on that triangle. So from that, I get the law of sines. and that is that the sine of alpha over A is equal to the sine of beta over B, which is equal to the sine of gamma over C.